Scientists just created a 24,000 mini universe to test if time emerges from entropy rather than being a fundamental force. Now, for decades, this was just a radical mind bending theory whispered by quantum physicists behind closed doors. But right now, everything has changed. Physicists have actually done it. They have tested this idea inside a lab by trapping 24,000 ultra cold atoms and building an actual functioning mini universe from scratch. A team of scientists just proved that time is not a fundamental property of our cosmos. Instead, it's just emergent, an illusion created by quantum relationships and the chaotic flow of information. Now, today we are diving into one of the most profound scientific breakthroughs of our era. We are breaking down the jaw dropping experiment from the University of Birmingham, exploring why ultimate equations of physics have been trying to tell us time is a lie for nearly 60 years, and revealing how modern quantum computing systems are rewriting our understanding of space, time, and existence itself. So let's enter a universe without time. Now, to understand how scientists managed to catch time disappearing in a lab, we first have to understand why they were looking for its absence in the first place. It all goes back to the clash of titans in physics. On one side, you have Albert Einstein's general relativity, where time is flexible, stretching and wrapping depending on gravity and speed. On the other side, you have quantum mechanics, which views time as a rigid, external ticking clock that dictates how subatomic particles behave. When physicists try to unify these two theories into a single theory of everything, they ran into a catastrophic roadblock. In 1967, physicists John Wheeler and Bryce DeWitt successfully combined them into a master equation framework for quantum gravity. It's called the Wheeler-DeWitt equation, one of the holy grails or headaches in quantum gravity. It describes the entire universe as a single timeless quantum state, everything frozen in a big, unchanging wave function. When they looked closely at the math, they discovered something shocking. There was no time in it, none. The variable t, which stands for time in almost every physics equation you have ever learned, completely vanished. According to the ultimate mathematical description of our universe, the universe doesn't evolve, change, or move through time. It simply is. It's a single frozen, unchanging quantum state, a cosmic block where past, present, and future all exist together all at once. Yet, here we are experiencing time flowing from past to future. Why? This left physicists with a terrifying paradox. If the fundamental equations of reality say time doesn't exist, so why do you and I experience a seamless flow of moments? The answer is a concept known as emergence. Think of it as a digital photograph. If you zoom into a single pixel, there is no face or landscape, just a single dot of color. But when you zoom out and look at the millions of pixels interacting together, an image emerges. For decades, this was just philosophy. But a physicist named Giovanni Barantini decided it was time to move past the math and prove it in reality. In a groundbreaking study published in Physical Review Research, Professor and his team at the University of Birmingham decided something straight out of science fiction. They created a miniature controlled universe in their lab to see if they could watch time manifest out of nothing. But how do you build a mini universe? Well, you start by eliminating the outside world. Why? Because in the early universe, right after the Big Bang, entropy was low. As it increased, the arrow of time pointed forward. This mini universe lets us simulate that in the lab. The team took approximately 24,000 rubidium atoms using precise high-powered laser. They trapped these atoms and blasted them with energy to slow them down until they were cooled to a mere fraction of a billionth of a degree above absolute zero. At this mind-numbing cold temperature, something magical happens. The atoms lose their individual identities and condense into a single exotic quantum state of matter called a Bose-Einstein condensate or a atom slushy. Now, within this quantum mini universe, there are no clocks, there is no external timekeeper. The system is entirely isolated. To test how time behaves, Barantini did something incredibly clever. He divided this mini universe into two distinct sectors, an observed part and an unobserved part, using two laser beams of different frequencies to create a thin barrier splitting the cloud into a bright observable region and a dark hidden region. The bright region, it repeatedly expands and contracts like a miniature Big Bang followed by a big crunch. Now think of the unobserved part like the mysterious dark matter and dark energy of actual universe. It's there, interacting but hidden. The whole system is completely isolated, no outside influence. Now here's the genius part. They could reconstruct the entire sequence of events from inside the system using only changes happening within it. As the observed part interacted with the unobserved part, something incredible happened. They weren't just exchanging energy, they were exchanging entropy, which is essentially a measure of randomness, disorder, and quantum information. As atoms tunnel or move between bright and dark regions, the distribution of particles in the bright sector changes. When entropy increases or redistributes, the system moves forward in time. When the distribution stays the same, time effectively stands still in this framework. Barantini realized as this entropy followed, the relationships between the particles changed. If you look at the system as a whole from the outside, it remains static and unchanging, just like the Wheeler-DeWitt equation predicted. But if you sit inside the observed part of the system and look at its changing relationship with the unobserved part, a clear chronological sequence of events form. This is what scientists call entropic time. So Barantini and his team even rewrote a version of Schrodinger's equation using this entropic time. It still predicts how the quantum probability cloud evolves perfectly. The problem of time in quantum gravity has puzzled giants like John Wheeler and Bryce DeWitt. In a truly quantum universe, how do you define before and after without an external reference? Well, this 2026 experiment is the first controlled lab evidence that time is not the fundamental pillar of existence. The mini-universe didn't need an external parameter to order its events. Its own internal entropy flow naturally created the tick of a clock. Even when the entropy exchange stops, time literally stands still. What this means is mind-boggling. It implies that time is entirely relational. It only exists because parts of universe are looking at and interacting with other parts of universe. Now this brings us to a revolutionary concept called time without time, heavily rooted in what's known as Page-Waters mechanism. Back in 1980s, physicists Don Page and William Waters suggested that quantum entanglement, the bizarre phenomena where two particles become deeply linked across space, is the actual engine that generates the illusion of time. Like imagine an outside observer looking at the entire universe from an external cosmic perspective. To them, the universe is a single entangled static state. No time passes, it's completely frozen. But if you are an observer inside that universe, you are entangled with your surroundings. As your quantum state shifts relative to the objects around you, your brain reads that shift, and that's the passage of time. Your aging, memories, cause and effect, all are tied to the entropy increase. Time is the price we pay for being the part of this system. It's an illusion born out of quantum entanglement. The University of Birmingham experiment gives a quantum foundation for that macroscopic arrow. By manipulating the flow of information between particles, they could literally speed up, slow down, or stop the internal time entirely. This laboratory breakthrough aligns perfectly with the recent staggering updates coming out of the world's most advanced quantum computing facilities, including Google Quantum AI. For years, tech giants like Google have been building quantum processors to solve the complex calculations. But recently, physicists have realized these quantum computers aren't just calculators. They are the ultimate simulator rigs for reality itself. By precisely controlling entangled qubits, researchers have been able to simulate advanced quantum systems that mimic the fabric of space-time. When you combine the physical laboratory results of Barantini ultra-cloud atom experiment with the massive processing power of modern quantum simulators, we are witnessing a monumental paradigm shift. We are moving away from a universe made of matter moving through space and time and moving towards a universe made purely of information. If time isn't fundamental, it changes everything we think we know about our cosmic history. Was there really a Big Bang? Or was that just a moment of our quantum information becoming complex enough for time to switch on? And if time is just a byproduct of entropy and entanglement, could we theoretically manipulate those quantum relationships to skip forward, backward, or step outside of time altogether? The classical world tells us that clock always ticks. It's inevitable. But the quantum physics is pulling back the curtain on a much grander reality, one where the universe is just a timeless masterpiece and we are simply experiencing it frame by frame. So, what does this mean for you? If time emerges from entropy and internal relationships, the universe might be a vast, timeless quantum state, and our experience of time is like a story unfolding from a correlation inside it. Barantini himself says it provides new insights into quantum gravity dynamics, usable and as effectively as conventional time. What are your thoughts on this mini universe experiment? Does it freak you out that time might be an illusion? Let me know in the comments below, and remember, the arrow of time is pointing you towards like and subscribe button right now. I will see you in the next moment or whenever it emerges.